Hey, hi. In this video, I'm gonna show you how to configure and use Kubecost on Amazon EKS cluster for cost visibility. As you see in this PPT, this PPT depicts my demo. Here, I'm gonna walk you through, how we need to set up the EKS and how we can configure the Kubecost on the Amazon EKS. And finally, we're gonna see how to access the Kubecost dashboard and see the visualize the cost usage of your Amazon EKS cluster, right? So this, if I can tell you in a layman term, the Kubecost is a the open source service that you can install on your Amazon EKS cluster for having an observability layer on cost or cost expenses basically on your EKS cluster. Yeah. So as you see in this PPT, as usual, this PPT depicts my demo here. So here what we're gonna say is we're gonna see like how we can set up a Amazon EKS cluster with using EKSCTL utility, and then on top of that we're gonna configure the Kubecost as a pod or as a service, and then we're gonna access that particular pod from the internet and see that how does that Kubecost UI helps us to get an insight about cost uses of our Amazon EKS cluster, right? So here the steps are very simple. The first step, which includes like the developers like who gonna manage us the Amazon EKS cluster, we're gonna configure the cluster, right? So then customer will deploy, in the sense basically the user will deploy a Kubecost with the single Helm command. The process here is very simple. The installation and configuration of Kubecost is a matter of just a Helm command basically. Yeah, this the Kubecost container image is being hosted on public repository, public Amazon ECR repository. From there, this Helm chart will extract that image and configure it on your Amazon EKS cluster, right? And then finally, once the parts are up and running fine, which is belongs to the Kubecost, then you can access the service. Yeah, so basically this Kubecost service has an UI, and you can access that UI with using the multiple methods, say the port forwarding method, or you can host a load balancer in front of that and access it, access the services from the internet basically. Yeah. And finally, customer accesses the Kubecost dashboard to start the monitoring of Amazon EKS cluster. So that's the fourth point, which is nothing but once you have configured the Kubecost, the for example, say that EKS cluster is hosting an application or a very big business application in that case. So the team belongs to that application can have a visibility on how does the EKS cluster cost aspects are doing. Yeah, so that's the main aim here, right? So let's say you are hosting very bulky, very huge Hulk type of cluster. So then in that case, it makes sense for you to have a cost visibility, right? So under the hood, this Kubecost is not doing any magic, but it actually under the hood, it's scraping the the AWS billing APIs and and putting it in a form of Prometheus database table, and finally from that it is also trying to visualize in the form of a nice dashboard or nice UI, which will help us to which will help a layman to have a cost observability basically. Yeah. All right. So for this demo case, I have already created my as usual help file here. So this help file contains the commands that you need to run to spin up a EKS cluster. So here I have already run all the commands that are needed to set up this this particular environment. Yeah. So for that case, here multiple prerequisites are there. First one is you need to have your system installed with the AWS CLI, that is AWS command line interface, right? And then you need to have your system installed with the EKS CTL, that is EKS command line utility as well. Then you also need to have a kubectl, the API interface has to be installed with in your system. That is in general, kubectl has to be installed in your system. So I have all these three prerequisites are been installed plus Helm, right? So your system also need to be installed with the Helm, because we are using Helm to deploy an application, that is Kubecost application, on the Amazon EKS cluster for cost observability purpose. Yeah, so what I do is I'm gonna show you the command which I use to create my EKS cluster. I'm gonna show you the output as well. I'm not gonna create or run the commands, but I'm gonna show you what are the paths I followed, and finally I reach to a space where I can see the cost observability of my EKS cluster. So here, to spin up the Amazon EKS cluster, I use a command called EKSCTL create cluster. This is the name of my cluster, and then I chosen the nodes, that is nodes is T3 large, which is a bare minimum resource configurable image. In the sense, this has a minimum like a 4-core CPU and 8 GB RAM, something like that, which is suffice for hosting these kind of services on your EKS cluster, plus while you are hosting your application as well. Then by default I'm keeping 3 nodes because so that to not to throttle the the resources required for this application. Then we have a minimum and maximum node group configurations has been done. Then I'm hosting in a US West one, and then in that one I'm choosing the availability zones, that is A and B, and finally choosing a version that is 2.6. So basically 2.6 is not supported by EKSCTL, so I chosen 2.4. I'm going to show you that in a couple of minutes. So this is the command I used. So before I run this command, I'm going to walk you through the setup I did. As I said, I have an AWS CLI installed in my system. That's the reason I'm using AWS CLI to set the context of my AWS account, that is AWS configure. Then this is my access key ID, which is already set as an environmental variable. Then we have a secret access key. Then the region, this is a region where I'm creating my EKS cluster. Make sure that this region is equivalent to the region where you want to host the EKS cluster. Yeah. And then you have a default output format equal to JSON. Yeah, then what I did is I'm going to check whether I really set the context properly or not by running a command called AWS STS get caller, STS get caller identity. And if that returns something like this, that is something like the JSON dictionary, something like this, then which means that yes, you are set the context. Yeah. And then what I did is, as I said, I try to create an EKS cluster of version 1.2.6, which is n minus version of current EKS availabilities. But looks like EKSCTL is supporting up to 1.4. Unfortunately, it's not supporting 25, 26, and 27. Yeah. So in that case, what I did is I reframed my command by using the version equal to 1.24. And then EKS cluster provisioning task has started. You see all those blue marks, all those blue logs are nothing but the EKSCTL logs, EKSCTL commandlet execution logs. Once you see this command, at the end saying like, your cluster with the name, this is Kubecost demo. I given my cluster name as Kubecost demo because I'm giving the Kubecost demo, right? So then I'm using this is the reason. So if you are seeing this command at the end, which means that, your cluster is rightly set up, right? And also it has backend, it also configured the .kube and config file is being configured as expected. So after this one, you can go to your AWS account. So this is my AWS account. If I can refresh, so currently I'm in my AWS account, so don't get confused. This is my AWS account, and currently I'm in a Oregon region, that is US West one, and then I have a cluster with a version like 1.24, and it is up and running fine. So consider this is the stage where the cluster is up and running fine. This cluster creation process takes nearby 15 minutes. That's the reason I already pre-created it for the demo purpose. Yeah. And then what did I do is I just wanted to check my kubectl configurations are working as expected. To check that, what we generally do is we run a command that is kubectl get nodes. As I expected that my 3 nodes are up and running fine, and the status of those 3 nodes are ready. Yeah. All right. So then what did I do is so there is a basically few learnings I got to know while I was preparing for this lab. So what is that learning? Let me explain you by following these commands. Yeah. So next one, what I did is I directly jumped to create the Kubecost, or to host the Kubecost on my Amazon EKS cluster by using this Helm command. Right. I missed some prerequisite, which are those I'm going to explain you in a couple of minutes right down the line. So here what I did is I run a command called Helm upgrade, and then it is, and I'm also directing it to install the Kubecost, belongs to this categories. Yeah, this is OCI category. Yeah. And then the version is something, this is the latest Kubecost version, that is publicly available version. And then the namespace is, this is the namespace. Basically it's gonna create a new namespace in your EKS cluster called Kubecost. And then I'm also feeding a parameter called create namespace. And finally the path of the the YAML file, that is Helm YAML file, is something here, that is values.eks. So if you go to this particular repository, you're going to see this YAML file, and this is our file which is actually doing the magic under the hood, right? And then finally in the set parameters, I'm also setting that hey, you need to set up the so basically Prometheus configurable mat. This is something like the configurations saying like config map reload enabled or not, right? So that value I set it to false. And then once I hit enter, so basically it went through and it has successfully installed. If I go down, it has successfully installed the Kubecost. You see, it says, so it generally says, if you see the output, that is deployed, right? And it says Kubecost has been deployed, installed successfully. The rest all information down the line are info for you. And then what I did is I was excited and I just went to the next command called kubectl get pod -node -kubecost. That is, I just wanted to see whether my kubecast pods are up and running fine by running the commands called kubectl get pod hyphen kubecast. Then I came to know that so basically there are two parts which are related for this kubecast applications are still in pending stage. Why those are pending? Because I didn't satisfy or I didn't met the prerequisite for the kubecast. What are those? So if you are hosting any cluster of EKS type greater than 1.2.3, then there is a mandatory prerequisite to create a independent EBS volume on your EKS cluster. So that piece was missing, and then I realized that yes, I need to do a prerequisite. Okay, so for that case, what I did is I have already articulated how you need to create an add-on on your EKS cluster, that is AWS EBS CIS drivers need to be installed on your Kubernetes cluster. Then only the the Kubecost application will work. Yeah, and that was the prerequisite which I was missing. And then henceforth what I did is I took a U-turn. So how did I took a U-turn is basically I did uninstall the Kubecost which I installed previously with using helm command. So to do that, what I did is I did run a command called helm uninstall Kubecost. Yeah, then namespace is Kubecost. Basically, it just uninstalls the application Kubecost, and then finally I deleted the namespace. Okay, then my cluster became to the original mode, in the sense it reverted back. Since I reverted the configurations back, in the sense again my Kubernetes cluster became as usual normal. In the sense it became like a fresh Kubernetes cluster, right? Then I started with the prerequisite commands. That is first one is so first one is again I miss something, that is, but here note that to enable or to add some add-on drivers, add-on EBS CI drivers, you need to have a service account. And the service, to enable the service account on Amazon EKS cluster, you need to enable OIDC provider on the EKS cluster. And that piece also I was missing. I will tell you, I directly jump for creating the service account, because that is service account is needed to enable the add-on drivers, that is EBS CIS driver, right? So what I did is I run a command called EKS create IAM service account hyphen name of my service account. Then the namespace is kube system. Then the cluster is my Kubecost demo. And I attached the native policy of AWS called Amazon EBS CIS driver policy. Then finally auto approved commands are being passed, and then the role name is something like this I given. But what it throws, it says hey, your cluster is not contain OIDC provider. Yeah. So then in that case, what happens is so you must enable OIDC provider for your EKS cluster. So I will go to the next command. So that is the command where I actually executed to create the OIDC provider on my EKS cluster. The command is ekctl utility associate IAM OIDC driver. Then this is the cluster parameter. So in that one I'm passing my parameter, that is my cluster name. Then finally I'm saying auto approve. Yeah. So once you run this command, then on your EKS cluster, the the OpenID Connect authentication provider will be installed on your Amazon EKS cluster. And if you see this output, so then yes, that it has done the job. Then let's go to the next command. So the next command is actually I'm just going to show you. So next command is create a create the service account in the EKS cluster needed for EBS CIS drivers, right? That is, the command is ekctl create IAM service account hyphen the name of the service account I'm just giving like EBS hyphen CSI controller, but this can be given according to your choice. Then the namespace we are keeping in a kube system only. The cluster is, this is the cluster name, and attaching the policy. To attach the policy, the policy which we created above has to be given as a policy here. So for that we are passing the ARN of the policy that we created above. So if I go above in the service account, right? So when you create a service account, it does creates a policy, right? Yeah. So that policy ARN has to be passed in here, right? All right. So remember that whenever you create a service account, and to that service account you are basically so you are basically you are basically adding a IAM policy to that service account. In the sense, on EKS cluster you are creating an account, and that account has the IAM policies basically, and that policy ARN is being passed here. I'm going to show you that. And then rest all commandlets are passed as usual. Then once I run this command, basically my EKS service account got created as expected. Yeah. Then let's go to the next command. So the next command is actually to create an add-on on Amazon EKS cluster. So for that case, I need the service account role ARN. Yeah. So remember that EKSCTL create service account is nothing but it creates a role in the IAM service of your account. You can find that role from there. Yeah, and also to that role we will be attaching a policy called, this is the policy ARN which we attached in that command only. Yeah, now once that service account is created, you can get the ARN of that service account, and then that would be used to create a add-on, right? So to get the ARN of my role called Amazon EKS EBS driver role, I just run this command called CLI command, that is AWS IAM get role. This is the role name and the output is JSON. And in the output, I see that the ARN of my role is something like this. Yeah, all right. So I got to know the ARN, then I'm good to run the next command, that is actually create an add-on. Yeah, that is EKSCTL create add-on. So I'm going to show you that command. That is the next command that we run is the one I'm selected. Okay, so please follow whatever the selection I'm doing in my video, right? So it contains this is the help file which contains the commandlet serialization. Anyways, this file will be shared in my GitHub repo, and the GitHub repo link will be provided in my video's description. You can find it from there, and you can just follow the commands. Yeah, you're gonna end up with installing the kubecast on your EKS cluster. So now what we are doing is we are adding the EKS add-on, that is kubectl create add-on. The name of the add-on is AWS EBS CS driver. This is a cluster. This is my role. Yeah, and then finally saying force it, just to create the add-on forcibly. And then once you see that creating the add-on is complete, then the prerequisite of your Amazon EKS cluster is done. Now next command is as usual I explained in the first step, right? There we directly jumped to install the Kubecost on the EKS cluster, but that failed because prerequisite was not there. Now we met the prerequisite. Let's try to rerun the same command. That's what I did it. That is Helm upgrade, install the Kubecost. This is the OSC, OCI path, and this is the version of which is the latest Kubecost version. The namespace is Kubecost. Create a namespace. Yeah, and then this is the file name, and then we are setting the parameter. Yeah, this is the same command which I'm running it again, but this time it will be doing the job as expected. Yeah, so this will get. So have a patience here because it's going to take like couple of 1 minute or 2 minutes. So then once it is installed, you can go ahead and check the pod status. Now it will be running. That's what I did. That is kubectl get pods. This is the name. This is the kubectl get pods hyphen my namespace, that is Kubecost. And you see that the primary parts of the Kubecost are up and running fine. That is cost analyzer, state matrix, Prometheus servers are all running fine. Yeah. And then that's all. So basically once you see that all the three parts are up and running fine, which means that your EKS cluster is completely hosted by the by the Kubecost application. Now you are ready to use it. To use that, I'm just very lazy because I am not hosting any load balancer in front of this service, but or ingress in front of that service, but I'm just using the port forwarding method, because in this I'm just just getting you to know about what is Kubecost, how to configure and how to use it. Yeah, so here I'm using port forwarding method. Let me re-forward it again. So just I'm gonna see control C. I'm just coming out of that, and then I'm gonna rerun the command again. So I'm just gonna rerun it. So what we are doing is we are running a command called kubectl port forward. This is the namespace, and this is the deployment. Okay, so this is the name of the deployment, that is Kubecost analyzer. Yeah, so how do we know that what is the name? So that will be coming here. So if you go here in the Kubecost analyzer, so this is the namespace. Yeah, and this is the configurations. And then if you go to the this one, if you go to this value.eks cost monitoring, you will see that deployment name equal to something like this. Yeah, and that is the name you have to forward, give it while port forwarding, and plus you need to give the namespace and the port that you need to forward on that. Yeah, that here is the 1990 port. So I'm gonna re-forward it again because earlier it was already been forwarded. All right, so it has started, that is to forward the port on this one. You can just go and copy this particular URL and try to open the same URL in the internet. Yeah, so I'm going in my Google Chrome and just hitting the enter, and it should redirect us to a Kubecost. So I'm gonna close the other instance. So this is the instance. If you see here, it's been a while that my EKS cluster is up and running fine. On top of that, I have installed the Kubecost application. Now it has started to gather the data, that is cost related data, right? So every application, everything in the world is cost, right? So cost is very important, and we need to have a visibility on the cost or observability on the cost. Yeah, so basically, so this is very important task. And if you see here, this is very nice dashboard. it gives you like end-to-end visibility, like which component is eating how much dollar and how much dollar it's gonna burn. And I know it's gonna give the foresight as well. So yeah, if you see in the overview, so overview is a kind of a summary of the complete functionalities of this Kubecost. It has a Kubernetes cost. You see the total cost of that particular cluster till now is $0.13. Then the total cost it is gonna summarize. This is possible monthly savings. I think I am missing something configuration, so that's the reason it is not showing here, but it's gonna use it. The cluster efficiency is something like 1.2%, which is very very less. And then if you go here, that is the the cluster level breakdown in the sense. So this Kubecost is not only for one EKS cluster. You can add on multiple clusters as well and have a nice visualizer dashboard as well. So here are the cluster node trend as well. You can see here, and you have the namespaces. Currently, you can see our namespaces like Kubecost that we created, and we have a cube system as well. And then you have a namespace trend. So in the sense, which namespace is eating how much. So here we have a two namespaces, and one namespace is eating $0.09. The other one is eating like the $0.04. Yeah. So likewise, if you go down, so again you will have a more insights, and we also have a further monitorings as well. So if you go to the monitoring options, underneath that we have allocations, right? This is a cumulative cost allocations. The data will be populated here. And then you have asset discoveries in the sense your cluster will have multiple assets. Say node, cluster management, disk, everything are the assets of the clusters. So on that top of level, you're gonna have the cost observability as well. That is a node level, and then we have a cluster management level as well, and then we have a disk management. So in total, these are the three important assets of the clusters are been identified, and then the cost consumption on that particular component is also been discovered, right? Think that how much visibility it is going to give you. I really like this particular tool because it is giving you in-depth analysis about the cost consumption, and later you can make a very nice plan on your the cost control or cost effective methods can be detected with using these dashboards. And this is our cluster. So this is the cluster which is eating that that is the total cost is $0.13. So if you can expand this one, you're gonna get more data on this cluster. Yeah. And this is a very nice dashboards here. So if I go to the reports, you can generate the reports, you can detect the add the savings as well. You can have the alerts, you can have the health as well. If you go to the health, it is having so many health capabilities as well. Then the governance can also be added. Yeah. And then the clusters, multiple clusters can also be clubbed on the same Kubecost, in the sense you host the Kubecost on the Amazon EKS cluster. Yeah. And then to that EKS cluster, you can append the another cluster to forward the the costing data and try to visualize from the single dashboard. Okay, so not only like what does that mean, in the sense you identify one cluster, on that cluster you host the Kubecost application, let you have like n number of other EKS clusters are there. You can point those EKS cluster to the same Kubecost instance hosted on a particular EKS cluster, and then you can do a switch context and visualize the data consumption on the the dollar consumption on the particular EKS cluster. Yeah. All right, so with that note, I have shown you the things need to be shown in this video from scratch to end, how to configure, how to see, how to use it. Yeah. All right, so with that note, thank you very much for watching my videos. A kind request, please do subscribe my channel. That would really encourage me a lot. So with that note, thank you. Thanks a lot, and see you in the next video.